Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, my co-host Henry and I are going to discuss a different approach to building machine learning models. This topic is based on a tech blog titled Video Annotator, a framework for efficiently building video classifiers using vision language models and active learning, written by the Netflix machine learning engineering team. You can find a link to the blog in this episode's description. Throughout this episode, we'll break down the topic from both business and data science angles. Now, let's dive in. On the business side, let's first explore the problem that needs solving.
What is Netflix and why do they need machine learning models?
Netflix, as we all know, is a global streaming giant with millions of viewers worldwide. They offer tens of thousands of titles, including kids' favorites like
Pokemon.
To provide a personalized experience at scale, Netflix relies heavily on machine learning models. Machine learning has a wide range of applications at Netflix, and one of their key business needs is granular video understanding. This involves developing machine learning classifiers that can identify visuals, concepts, or events within specific video segments. Why is it important? Video understanding is fundamental for various applications like search and discovery, personalization, and even creating promotional assets. For example, when it comes to search and discovery, Netflix needs to identify specific moments in a show or movie to recommend content based on viewers' preferences. Imagine searching for action scenes or romantic moments. Without accurate video understanding, Netflix wouldn't be able to make those nuanced recommendations.
How do they build machine learning models for video understanding and do they face any challenges?
Great question. Traditionally, building machine learning models follow a more classical approach. Domain experts manually annotate large video clips with specific data points. For example, tagging each segment as an action scene or romantic moment. These annotations are then handed off to data scientists, who train the models, review the results, and iterate. While this approach might work, this method is far from optimal. It's resource-intensive and time-consuming, as in each cycle of annotation, model training, and review takes a lot of effort. Often, progress is slow after a few cycles due to the sheer volume of data required. Let's say if Netflix wanted to train a model to recognize a genre like sci-fi adventure, manually annotating countless hours of footage would demand enormous human labor, making it inefficient and costly. That's a challenge Netflix team faces, and it is why they are developing solutions to address it. Now that we've understood the business problem, let's shift gear and dive into the technology side to see what is in the solution. This specific machine learning needs for video understanding is to develop video classifiers. These classifiers assign labels to video clips of various lengths, often with a probability or prediction score. The team opted for binary classification models, which determine whether a video clip belongs to a specific label or not. This approach offers flexibility, allowing the team to add or improve one model without affecting the others. To scale the development of these classifiers, the team created a system called Video Annotator. This system enables video experts to directly contribute to training machine learning models through a three-step process. Step 1 is search. Users begin by searching for an initial set of examples from a large, diverse video corpus to jumpstart the annotation process. For example, a video expert working on a model for establishing shots might search for wide shots of buildings. The system then returns clips that match that concept. This is made possible because the system uses text-to-video search, powered by video and text encoders from a vision language model. These encoders create numerical representations, or embeddings, for video and text. It allows the system to calculate similarities and find relevant clips. Step 2 is active learning. In this step, the system builds a lightweight binary classifier based on the video embeddings and scores all clips in the corpus. It then presents different feeds for further annotation. There are different categories, including top scoring positive examples, top scoring negative examples, borderline examples, and random examples. Positive and negative examples help the user to determine whether the classifier is picking up the correct concepts and can highlight the biases in the data. Borderline examples, where the model is uncertain about them, helps to surface interesting edge cases and may inspire additional labels. The random examples ensures diversity in the annotation process, which is critical for model generalization. Users can label more clips, building a new classifier, and repeat the process as needed. Step 3 is to review. In this final step, the system presents users with all the annotated clips. This allows them to spot any errors and identify new ideas or concepts for further annotation. This often leads them to revisit early steps of refinement. Once this system was built, the team wanted to evaluate its performance. They asked 3 video experts to annotate 56 diverse labels across the video corpus of 500,000 shots. Compared to baseline method, the new system produced a higher quality classifier. This self-service approach empowers domain experts to make improvements without needing assistance from data scientists or third-party annotators. This fosters ownership and autonomy. The system also demonstrated a median above 8-point improvement in average precision over the most competitive baseline. This further reinforcing the trust in this solution. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we discussed the challenges Netflix faced in building machine learning models for video understanding. We examined their solution, a self-service system with active learning. It empowers the video experts to participate in creating and refining machine learning classifiers through a streamlined 3-step process. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.